Let's talk about that. Basically, everyone uses them, but almost no one knows how they are made. Well, that is going to change today, because we're going to check that out today. And it's not bottled water, it's tap water. But I just think for these water companies, all they really do is grab a bottle. They make, the only thing they make is the bottles, and even, I don't know that for sure, they probably just, go to a landfill, pick out all the bottles they can, and then put water in them, and say it's their own company. But, I don't know that for sure, but we're gonna learn how tap water is made, then we're also gonna learn about seatbelts, how they're made, so let's go. I would like when I'm in this studio here, I always like to get comfortable during these.
Selected photos 1 31 button. Selected screen recording video get this added skip ad.
Drinking water that's fresh, clean, and crystal clear is something many of us take for granted. We might not give it a second thought, but between the source and our tap, a lot happens to make that water fit to drink. Our water may come from Mother Nature, but it's far from pristine. It starts its journey to the treatment plant through a water intake pipe. On the wall of that pipe, about 2 meters down, is a 15-centimeter hole. Covering that hole is a metal grill designed to keep out large debris such as tree branches. The water flows to a pumping station where it goes through a preliminary screening. A giant revolving screen removes fish, garbage, and grass.
Is the mic on, did I?
Video 322 Control Center. Sprite cap select open controls. Selected photos 2 for mix microphone on button.
Once they remove the debris, a low-pressure pump moves the water into the treatment plant. The untreated water, called raw water, is dirty and smelly. So they first add a powerful form of the chemical element carbon, called activated carbon. It absorbs contaminants such as solvents and pesticides. That rids the water of bad taste and odor. From there, the water then goes through a series of mixing tanks. The first tank holds a chemical called aluminum sulfate. It acts as a coagulant, a substance that thickens liquid into globs. In the raw water, the aluminum sulfate forms tiny sticky globs called flocks. Bacteria, mud, and other impurities stick to those flocks. Then the flock-filled water moves on to the second mixing tank. The second tank holds a chemical called polymer, which is essential to the next step of the process, called sedimentation. 5 pipes inject the water with superfine particles of sand called microsand. The polymer coats the sand, making it sticky. The grains of sand then stick to the flocks in the raw water, weighing them down even more. The water then flows into a settling tank where the flocks, because they're heavier, settle to the bottom. You can see the results in this demonstration. The water is finally clear, but it's far from drinkable because it's still full of bacteria, viruses, and other organic matter. So on to the next step, filtration. The
goes
water
through it.
flows onto the top of the filter,
So is this
then
always
trickles
happening, I wonder,
downward,
like-
passing through a layer of anthracite, a type
does
of
that
coal,
work?
then through a layer of sand. This filters out any remaining particles, which then flow to the middle. But
Wow.
the water is still teeming with bacteria and viruses, so it has to be disinfected. They add 1.9 milligrams of chlorine per liter of water, enough to kill off those germs and bugs. They add a mineral called silicate to prevent calcium buildup
Wow.
from blocking our water pipes. The treatment plant sends water samples to government inspectors who continuously
tasting it?
monitor the water supply to ensure it meets safety standards. The amount of chlorine remaining in our drinking water is 0.6 milligrams per liter.
Wow.
The chlorine gas the plant uses is highly toxic. Should any leak out, emergency teams would have to evacuate a
How far is that?
10-kilometer radius. So the plant stores the drums of chlorine in a high-security area. It's taken about 45 minutes to turn raw water into treated water. Now these electric motors will pump it through underground pipes right to your tap.
I am Butch Loxon. I'm a Los Angeles-based artist. I'm
Video
inspired by
business
the
add
David
one
Letterman
add
tribute
add in
in Los Angeles.
Alright,
skip ad
seatbelts. Well,
button.
I didn't know
It's an
water was like that,
indisputable
but now
fact.
let's see how seatbelts are made.
That seatbelts save lives. When a car comes to a sudden stop, the seatbelt prevents you from hurling forward. It
Yeah.
spreads the stopping force across the sturdier parts of your body, namely your rib cage and pelvis. This spreading action dilutes the strength of the stopping force, minimizing injury. Before production can begin, the factory has to adjust the seatbelt design to fit the specific car model, to make sure the belt path is clear, that there's enough room for rotating parts to move, and so on. On the factory floor, robots assemble most of the mechanical components. This plastic disc, containing a spring and a weight, is part of the locking mechanism. It's what stops the seatbelt straps, called the webbing, from lengthening when you jerk forward due to a sudden stop or hard deceleration. The locking mechanism goes into the seatbelt's retractor mechanism, the component that lets the webbing extend and retract. The webbing will wind onto this aluminum spool in the retractor, a rewind spring keeping it taut. Sudden deceleration will cause this silver ball to trigger the locking mechanism. This will stop the spool from rotating and lock the webbing. This next robot assembles what's called the pretensioner mechanism. While the locking mechanism stops the webbing from lengthening, the pretensioner sharply pulls the webbing back, tightening any slack. The pretensioner kicks in only in the event of a crash. The sudden deceleration on impact triggers sensors which signal the airbag control module to send an electrical charge to the pretensioner. This charge sets off a tiny explosion that deslacks the belt. This worker installs the explosive device called the microgas generator, or MGG. After lubricating the inside of its aluminum cylinder with grease, she inserts a piston and the MGG. The MGG contains a chemical called nitrocellulose. The electrical charge coming from the airbag control module ignites this chemical, causing a tiny gas explosion. That generates pressure within the cylinder, driving the piston upward at high speed. This triggers a gear that winds the retractor spool backward, taking up any slack in the webbing. After capping off the microgas generator's
Hold on,
housing,
my robot,
a
sorry.
robot transfers the completed pretensioner mechanism to the retractor's frame. Then it screws on a steel cover plate to hold the pretensioner in place. They install the rewind spring onto the spool of the retractor mechanism. This spring is what provides resistance when you pull out the webbing to buckle up. Then when you unbuckle, it rotates the spool to rewind the webbing. The car company decides what type of spring to use. The thicker the spring and the more coils, the greater the tension, and therefore the faster and smoother the belt retracts. But the greater the tension, the less comfortable the seatbelt is on the body. The webbing is made of woven polyester fiber. This machine sews one end over into a loop for the pin that'll anchor the webbing to the spool. The pin is made of either plastic or steel, depending on the type of retractor they're using. A worker now threads the end through a machine that automatically winds the webbing onto the retractor spool, making sure the pin is properly attached. At the same time, the machine checks the overall belt length to make sure it conforms to the client's specifications. At this factory, every single seatbelt component has to pass a thorough quality control check. Here, a machine checks a key safety feature, a lever and ratchet mechanism that prevents the webbing from extending after you've belted in a child car seat. Now for the final assembly. Workers load all the seatbelt parts in a jig, a holding device that arranges them in the proper configuration. A worker feeds the webbing through the shoulder loop, from which the belt hangs, and through the tongue plate, the part that clicks into the buckle. Both these components are made of steel for strength, with plastic coverings matching the car interior. The last step is to sew the anchor to finish off the other end of the webbing. Every seatbelt design goes through extensive testing before going into production. This machine assesses how much pull the webbing and retractor can withstand before breaking. This machine tests the webbing's durability, running it through 50,000 abrasion cycles to ensure the material doesn't wear out.
Wow. So, turns out these products are made by robots and people. But I never knew any of this. But if you like the video, like, comment, share, subscribe. Sorry for all the commotion outside. Upstairs. And as always, be your mythical best.